Your Go programs are inefficient because you're not using context for timeouts and cancellations. In today's video, we're going to talk about one of the most useful tools in Golang for managing timeouts, cancellations, and request lifecycles, context. If you're building web services, APIs, or any concurrent application in Go, mastering context is a must. Let's break it down. In Go, context is a way to pass deadlines, cancellation signals, and other request scope values across API boundaries. It's widely used in server-side programming to manage request lifecycles, ensuring resources are cleaned up properly if a client disconnects or a timeout occurs. For example, if you're handling a request and it takes too long to complete, you might want to cancel the operation and free up resources. That's where context comes in. Let's start by creating a simple context and passing it into a function. In this example, we use context.withTimeout to create a context that automatically cancels after 3 seconds. The DoSomething function simulates a task that takes 5 seconds. If the task isn't completed before the context times out, it cancels the operation and prints a cancellation message. Let's consider a more practical example. Imagine handling an HTTP request where we want to ensure a database query completes within a certain time, or the request should be canceled to free up resources. Inside the HTTP handler, we create a context with a 2-second timeout using context.withTimeout. The query database function simulates a database query that takes 3 seconds. Since our context times out in 2 seconds, the query gets canceled. If the context is canceled, the server responds with a request timed out message. One of the best practices in Go is context propagation. When working with multiple functions that rely on the same cancellation or timeout signals, pass the context down through your function calls. That way, everything operates under the same time constraints or cancellation signals. We pass the context from process request into fetch data. Fetch data creates a new context with a 2-second timeout, but the operation itself takes 3 seconds, so the function returns a timeout error. This demonstrates how context can be passed between functions, ensuring that the same timeout and cancellation signals apply throughout the request flow. Pass context as the first argument. Always pass the context as the first parameter to functions that require it, like funcMyFunction, ctxContext, context. Avoid storing contexts. Don't store contexts in structs or global variables. They should be passed directly to the functions that need them. Handle errors from ctx, done. Always check for and handle errors from the context, particularly for timeouts or cancellations. Cancel the context. Always call the cancel function returned by withCancel, withTimeout, or withDeadline to avoid potential memory leaks. If you missed our previous video on Defer in Go, make sure to check it out to understand how Defer can simplify resource management and prevent leaks.